Hello my geometry class, and welcome to our next video lesson. This lesson is going to be about section 11-6, which is about arc lengths and areas of sectors. If you would like to follow along in your book, it begins on page 452, but I would ask that all of you take notes on this just as you would in class. Now, there are two terms in the title here I want to make sure we're familiar with. One of them we have seen before, and one of them we have not seen before. The first is arc, and the second is sector. Now, an ark we should all be familiar with. We know that Noah built one and the animals came on and there was a flood and, different kind of ark. In geometry, an arc is a section of a circle. So if I have a circle here, just give it a center O, and I have points A and B on this circle, the piece of the circle that connects A and B is called arc AB. And this should be familiar to all of us by now because we have seen this on several tests and quizzes, but good to review still. Now, a sector, that is a new term for us. And a sector, the simplest way to think about it, and the way I'm going to start you thinking about it, is it's the shape of a slice of pie or a slice of pizza. They are not triangles, they are sectors. It's a shape that, and this is the more geometrical definition, it's the shape you get when you in a circle that's bounded by two radii. So it's the region of a circle bounded by two radii. So in this circle here, let's say I draw a radius OB, because O is the center, and OA. Then this whole region here, this AOB region, is going to be a sector. It's going to be sector AOB. Now, we don't really have much of a way of writing it. Like, we can write arc AB, but for a sector, we're just going to write the word sector AOB. Note that sectors are composed of two segments, which are the radii, and a piece of a circle. So it's not a polygon because it doesn't have all straight sides, but it's a piece of pizza shape. So this is our sector AOB here. You could also think of it as it is an arc whose endpoints are connected to the center. So we have arc AB, and then B is connected to O, and A is connected to O. Note that it has to go to the center. If it goes to any other point in the circle, it does not count as a sector. So if I have a point over here, and I make this area right here, that is not a sector. It's only the blue region here that is the sector. So, the goal of this lesson is to find the length of arcs and the areas of sectors. And this is going to be, as you might guess, very connected to our previous lesson in which we find a circumference of a circle and the areas of circles. Because arcs are just pieces of circumferences and sectors are just pieces of circles, we can use that same idea to find these pieces of the circle then. So, let us start by considering somewhat of a simple example. So let's say I start with a circle, and let's say this circle has a radius of 1. We'll keep it nice and simple. And let's think about if I draw a diameter in here, so this other piece is also going to be 1. And I'm going to make the center of this circle O, this endpoint A, this endpoint B. I'll put a C down here as well. Why not? So, let's say that we want to find the length of arc ACB. How are we going to do that? If you would like to pause the video and give it a shot on your own, go for it. You can do that right now. And I'm going to go ahead and solve it. And this is going to be kind of a simplified way of thinking about it, and then we'll get more of a formula that we can use after looking at some simple examples. So, what I'm going to suggest we do is find what the circumference of the whole circle is. Because we know a diameter splits the circle in half, we can accurately assume that this arc here is going to be exactly 1/2 of the circumference. So the circumference is going to be 2 pi r, or pi d. So 2 times pi times the radius, or pi times the diameter. That was our last lesson. And because I know the diameter is 2, let's just say that the circumference is going to be 2 times pi, which is 2 pi. Now, I know that this arc is 1/2 of the whole circumference, and so this is just kind of hypothesizing right now. Let's assume that it is going to be 1/2, and we will find out that it is later. And we can say that it is 1/2 of 2 pi, so the length of arc ACB is going to be equal to 2 pi over 2, which is 1/2 of 2 pi, and that cancels out to just pi. So this length right here is going to be pi. Now let's do the same thing for the area here. As you might guess, this splits it into 2 semicircles, and each semicircle is exactly 1/2 of the whole circle. So this semicircle, which is actually just kind of a funny shaped sector, sector AOB, is going to be 1/2 of the total area. Now the total area is going to be pi r squared, so I'm going to say area of, I'll put a little circle there so we know it's a circle. The area of the circle is going to be pi r squared, so we have pi times r, which is 1, and we square that. 1 squared is 1. So the area is actually just going to be pi, very conveniently. And so if we look at then the area of sector ACB, it is going to be 1/2 of the area of the whole circle, which is going to be pi over 2, 1/2 of pi. So this is a very simple example to start with, but we're going to use this to talk about how we can calculate the area and length for any sector shape that we might be given. So let's think in terms of arc measures and angle measures here for a moment. If this is a diameter here, the measure of angle AOB is going to be 180 degrees, right? And so this arc ACB is also going to be 180 degrees. Now, how many degrees are there in a circle? There are 360 degrees in a circle. So what we could do is we could talk about arc length and sector area in terms of like a proportion or a fraction of the whole circle. So if we know there are 360 degrees in a circle, and this arc takes up 180 of them, we can make a proportion 180 divided by 360. So 180 over 360 times the total circumference, which is going to be, we said, 2 pi, or sorry, times, not equals, times 2 pi. That's going to be the length of our arc there. So this 180 divided by 360 ends up being 1/2, and 1/2 times 2 pi is going to be equal to pi. Now I'm starting to run out of room here, but I'll see if I can squeeze something in here over on the side. Let's do the same process for the area of that sector AOB. So we know that there are 360 degrees in a circle, and this sector, that kind of central angle of the sector, uses up 180 of those degrees. So we have 180 degrees divided by 360, and we multiply that ratio by the area of the whole circle, which we said is pi. And then, once again, 180 divided by 360 is the same thing as 1/2, so this equals 1/2 pi, or pi over 2. So these are the same thing here. Now, that's the exact same process that we're going to use for all of our problems in this section. Let me get a new whiteboard sheet. So, there's a purple box on page 452, which we have come to love purple boxes. And the way it might look confusing when you look at it at first, but when you think in terms of what we just did on that page over there, it'll make the purple box make a lot of sense. So if you're given a circle with a center, say, of O, has a radius of R, and you have points A and B, and we're going to call this arc measure here x degrees. If we're looking for the length of arc AB, it is going to be the proportion or the ratio of that arc measure over 360. So it's going to be x degrees out of 360, and it's going to be multiplied by the circumference, which is 2 pi r. So it looks like a complicated formula at first, but when you think about what's going on, it's not. This section 2 pi r here is just the circumference, and then you're just taking whatever proportion of the circumference you have. So if you have 90 degrees, that would be 1/4 of the whole circumference. If you have 60 degrees, that would be 1/6 of the whole circumference. And you can get that exact ratio just by dividing whatever your arc measure is by 360. If we're looking for the area of sector AOB, I'm going to write it down here. The area of sector AOB is going to be the same thing. It's going to be your arc measure divided by 360 multiplied by your area, which is going to be pi r squared. Sometimes you might know the area beforehand, sometimes you might not. You might just know the radius. Maybe you have to do something else to figure out the radius. So these problems can get more involved. But assuming you're given just the arc measure and the radius, you can solve these problems. And as long as you can get to those two pieces of the puzzle, you're good. You're set. So let's do a couple examples here. I'm going to work through a few of the classroom exercises. I'll just go ahead and start, and you can follow along. You can go ahead and pause and check your work against mine for each of these classroom exercises. So let's go ahead and get started. Get a new whiteboard. Oh, one comment though before we get to the exercises. Don't confuse the length of an arc with the measure of an arc. The measure of an arc is that degrees. The length of an arc is going to be, say, in inches or something. So the measure is degrees, the length is going to be the distance. Make sure you have those straight in your head, because it's very easy to confuse those, and you just want to make sure you have your terminology straight.